In this video, I'm going to explain some basic concepts in probability. Probability is about the study of random events. So first, a random experiment is anything we do whose outcomes cannot be predicted. So a simple random experiment is tossing a coin. Another one is tossing a die. Now, sample space S is just the list of all the possible outcomes. So if you are tossing a coin, S is just edge or tail. If you are tossing a die, then the list of possible outcomes is 1, 2, 3, 4, 5, or 6. So S is just the sample space, the list of all the possible outcomes of a random experiment. An event, E, is any subset of S. So if we are interested in the event that we get an even number when we toss a die, then A will be 2, 4, 6. The event B could be the event that we get a number more than 5, then B is 5 or 6. C could be the event that we get a 1, then C is just 1. One thing to remember is probabilities are always between 0 and 1. Probability of S is 1 because S will definitely occur. And for any event A, the probability of A is between 0 and 1. And we say that probability of A is equals to 0 if it will never occur, and probability of A is equals to 1 if it will always occur. A simple way to think about probability is by using a Venn diagram. In a Venn diagram, we use a rectangle S to represent the sample space, and then some shape inside S to represent an event A. And we can think of the probability of A as the area of A divided by the area of S. If we have an event A, we can talk about all the outcomes that are not in A, all the outcomes that are outside A. We call this A complement. And so A complement is just anything that is not A. If you look at the Venn diagram, you'll notice that A intersect A complement. In other words, the overlap between A and A complement is nothing. And A union A complement is the sample space. And therefore, we have this other result, that PA, the probability of A plus the probability of A complement, is always equals to 1. And this is a very useful equation because sometimes we are interested in the probability of A, but A is a really complicated event, and so this is hard to find. But A complement could be a simple event, and probability of A complement is easy to find. And then PA can then be found by taking 1 minus the probability of A complement. If you have the sample space S, an event A, and another event B, the event A union B is just A or B. And if you're interested in finding the probability of A union B, a simple way to think about this is by thinking about the area of A union B. And then you find that the probability of A union B is just the probability of A plus the probability of B minus the probability of A intersect B. And that's because the probability of A is everything in the blue part, the probability of B is everything in the purple part, but the sum of these two things includes the middle part twice. And so we have to subtract the probability of A intersect B once. Sometimes two events A and B do not overlap. If they do not overlap, we say that they are mutually exclusive. In other words, they mutually exclude one another. If I know that A has happened, if I have an outcome that is in A, we know for sure that it will not be in B. So B has been excluded. A and B are mutually exclusive means that A intersect B is empty, and therefore the probability of A and B is 0. Because it is never possible to have an event that is inside A and inside B if they have no overlap. If A and B are mutually exclusive, we have probability of A and B equals to 0, and therefore the probability of A union B, which we saw previously, was the probability of A plus the probability of B minus the probability of A intersect B, now becomes probability of A plus probability of B. That's because this probability of A intersect B is 0. And so to summarize, we have the probability of S is 1, probability of A is always between 0 and 1, the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. If A, B are mutually exclusive, then probability of A intersect B is 0, and we have the probability of A union B equals to the probability of A plus the probability of B. So that's all for today. Thanks for watching.